Hey guys, I'm Jade. Today is my LeetCode review vlog on the third problem, longest substring without repeating characters. We are given a string S. We have found the length of the longest substring without repeating characters. We got example 1 here. We got the input ABC, ABC, BB, and the output is 3 because the longest substring is ABC with a length of 3. And then let's get started with our intuition first. So my first intuition to solve the problem is a straightforward brute force approach. I can generate all the possible substrings and check each for uniqueness. And the detail is brute force. I'm going to use a 2 nested for loop to generate all the possible substring. Generate all possible substring. And then I'm going to create another inner loop to check for uniqueness. This is the first approach, and the time complexity, it is big O of n cubed, which is not efficient as we want. So we can come up with another better solution called sliding window with hash map. And the key point is we're going to use a map, to remember the last seen index of each character. So this would allow us to skip unnecessary characters efficiently. And then let's get started with our code right now. So the first step is we're going to create several variables to help us solve the problem. Let's say n equals s dot length and max length started at 0. And then we have to create a hash map to help us solve the problem. And character, the type of the key is character, and the type of the value is integer. Map equals a new instance of hash map. And then we'll have a for loop to help us solve the problem. Let's say int I started at 0 and j started at 0 too. And I stands for the start point of the sliding window, and j stands for the end point of the sliding window. And the condition to keep loop is j must be less than n, which is the length of the input string. And we have to increment j after each iteration. And inside for loop, the first key point we want to do is to check if the current character has been seen before. And the code is if map dot contains key. And the input parameter is s dot character at j. And if the condition is true, which means we found the duplicate characters, so we have to update the start point of the sliding window. And the code is I equals math.max of map.get s.character at j. And there's one thing we have to remember is we have to find the maximum value between map.get s.character at j and I. This is because we may found a smaller value of the index, and this index is smaller than I, and we don't want to move I backwards. This is because our sliding window has passed that index. So that's what we need to check. And the next step we're going to do is to calculate the length of the current substring. And the code is max length equals math.max of max length and j minus I n plus 1. And the next step is we have to update our map. We have to put or update the entry for s.character at j in the map, which is with its new index. And the code is map.put and s.character int j with the new index, which is j plus 1. This is because when we store j plus 1 as the index, which can ensures that when this character is encountered again, the start index I can skip directly to this index. And the final part, we just return max length we updated so far. And then let's check for the correctness. So for the second approach, sliding window with hash map, the time complexity, it is big O of n, as we only traverse all the characters for only one time. And the space complexity, time complexity is big O of n, and space complexity, it is big O of minimum of n, and m. N stands for the length of the input string, and m stands for the size of the character size, which is all the character set. And this is the end of my LeetCode review vlog on the longest substring without repeating characters problem. You can also visit my GitHub repository here and click this link to see the online guidebook of this project, which is here. You can see the detailed problem description and intuition and main idea and different approach with detailed code and time and space complexity analysis here. And thank you guys for your watching. I'll see you next time.